Hello, I'm going to now go through with you the activity for week 1 and explain what's expected for you. You will have already heard your teachers talk about this in class, but this is if you want to look further or want to ask more questions, you could use this video to help you, and then if you've got further questions, you can go back and ask your teachers. Fairly important in case you lose it that you pop your name on, so if your name's called Fred, then Fred will go up there. Now in terms of filling it out, the first thing that you're asked to do is you are basically asked, if we go and have a look here, is to come up with a drawing of safe practice or unsafe practice. So for example, if it's running, then you might want to go and show somebody running quickly, so we might go and do a little drawing of running. Now, would running be safe practice or unsafe practice? You'd need to have a little think, and press pause. Hopefully from your little think you've realised it is unsafe practice, so we might have the bench there with people working on there, and there may be other people around. Again, my drawing isn't fantastic. It doesn't need to be fantastic. The idea is the concept that you're getting across. So here's my other bench and the other person over there. There's the bench, and then you are running at high speed. So we'll put a big arrow on for the running, and then a big cross through it, because we don't want to have running. So again, very simple diagram. You may draw a much better diagram than I've drawn there. Going further down this list, other important safety rules. If you wanted to mention wear safety glasses as one of your rules, and I'll leave you to work out the other ones, then you just go and write in wear safety glasses. So write in the rules that you think that we have in this room for science. Okay. Now we move on to the scientific method and the key ideas. I won't do all the key ideas for you, but one key idea that we had very much for the scientific method, if I just move that down so I can type it in, or write it in, one very important key idea that we had for the scientific method. I might just change my colour to blue, it'll just make it easier for you to see what I'm writing in compared to what was typed. The first scientific method idea is that you keep everything the same except what you're testing. See if I can improve my English when I write it down, except for the property being tested. By property I mean the thing you're looking for, like the amount of fertilizer, the amount of light, if you're doing a light one. So for instance, if you were seeing how light affects plant growth, then you keep everything else the same other than the amount of light. If you're looking at how much fertilizer affects plant growth, then it would be keeping everything the same except for the amount of fertilizer being tested. So I don't mean by property something that you own. I'm talking about an actual thing that you might be looking for when you're testing. Okay, so a different use of the word property. Let's go down here now and look at your experiment. Hopefully you have done your experiment or you're underway with your experiment. Your first job now is to come up with the prediction of how many drops. So if you reckon it'll fit on 15 drops, you'd stick 15 drops in there. Let's go on to the next page. How do I do that? I'm thinking I just go like this. That's not going to work. I think I just need to I need to actually go to the next page on this app, so I'll go and do that now. Okay, we're now on the next page. Clearly that forms your hypothesis. So this is how you'd write an experiment up properly. The aim explains in simple terms what the experiment is. Above the aim you'll see there's a title, so if I go and sort of point this out to you here. Here's the aim, and it's a very simple paragraph of what the experiment's about. The hypothesis is your precise sentence. Remember, your hypothesis is always written in an active way. So if it's 15 drops, you'll go and stick your 15 drops there. I'd like you to think and put into those spaces the other 2 bits of equipment we were using. So I'll leave you to fill that bit in. Remember, you mightn't be filling in 15 for the hypothesis. Also, you'll be filling in whatever you think. Then you'll do the experiment and you will write in here your first attempt, your second attempt, your third attempt, the number of drops, and then you'll work out the average. If you're working out the average, remember you need to add up the numbers, so add up that one, add up that one, add up that one. When you've worked out the answer, divide that by 3 because there's 3 attempts, and that's how you work out an average of a group of items. We'll do average more in maths and we'll actually learn different types of average this year, but for now, that's what you'll need to do. Now in the next section over here, if I go down, you can get to start being creative. You might like to think of things that could be improved. For instance, you might think of, were all of the dropping pipettes exactly the same size, or did some of them end up producing bigger drops than little drops? Was the table still, or were people moving the table? Because that would make the drops easier to fall off if it was getting towards the limit of what would fit on the coin, because the liquid would wobble more. So there's things like that. See whether you can come up with some more ideas of your own. Then you can write it down if you like, and you don't want to write sentences. Write it down as a series of dot points. Your first dot point, your second dot point, your third dot point. If you can join it up as sentences, that's even better, but give it a go either way. So that's what we do on this page. You may have a few more dot points you want to put down, which you can pop down here. And then when you've finished your dot points, it's a fairly simple matter. If what you guessed was correct, then you will say it's supported, and if it wasn't, you'll say it's not supported, so that you'll be crossing off one of these. So if it was supported, then you'll be ditching the not supported one. You'll just cross that off, and therefore your sentence becomes a hypothesis was supported. A supported hypothesis means it worked, and not supported hypothesis means what you predicted didn't happen. If you find your hypothesis was not supported, it is no cause for worry. Some of the best experiments in the world that have changed our knowledge of science were experiments where people thought something would happen and then something different happened, and then they had to explain why that something different happened. So it is no reflection on you, or nothing to be at all concerned about if your hypothesis wasn't supported. The important thing is you did the experiment and you found out whether it was a yes or a no. That's the important thing. For some of you, that's going to be your expectation for this week. But for those of you moving on to the more extended levels, for instance, the beyond core and accomplished levels, you'll need to do a little bit more. And how we've structured that for this week is that you've got a couple of experiments to read. One experiment is clearly a better written experiment than the other one. So the first experiment is Conan's experiment. The next experiment, the same experiment as Kelly's experiment. The experiment is only written to the point of view of getting the results table down. Beyond the results table, there is no extra bits put in, because you'd have to do the experiment to be able to go beyond that point. And all Conan and Kelly have done is to actually come up with the design for the experiment. So this is now Kelly's experiment, and then you've got a series of questions today to do, and you can think through your answers here. In your opinion, which experiment was designed the best? Was it Kelly's? Was it Conan's? So that's what you're doing over here when you're thinking about finishing this answer. Next answer, what was the independent variable? Remember from what we learnt this week, the independent variable is the thing that you are changing. The dependent variable is what you're measuring. And finally, come up with some reasons of your own. I'm not going to give you any help here of how this experiment could be done better, so how it could be further improved. When you've done that, you've completed our expectations for you in science this week. Well done on a good first week.